What's up guys? Welcome back to Vanover Machine and Repair, and in today's video we're doing something outside of the norm. We're going to be doing a production run of 300 parts. Typically we focus on the one-off repair or manufacturing to get a customer back on the road or to solve a problem. In this case, the problem is making a bunch of parts efficiently in a manual only machine shop. So let me bring you in a little bit closer and show you the details of what we're going to be making. While we're on the way to pick up the material for this job, we need to think about ways to be creative so we can process this job efficiently. I got a couple tricks up my sleeve that we're going to show you. That way we don't go insane making this high quantity of parts in our manual only machine shop. Let's go ahead and address the elephant in the room, and that is, why in the heck are we making this manually? This is a perfect job for a CNC machine. And while that is 100% true, the fact is we don't have a CNC lathe, at least not yet. So instead of turning this job down because we don't have a CNC machine, we're going to go ahead and get it done creatively. And if we do enough of these jobs, we might be able to buy ourselves a CNC lathe in the future. Now I realize you still don't know what we're going to be making, and that may be intentional, to be honest. But we're going to get there as soon as we get this material opened up. And the first way that we're going to be as efficient as we can in this job is getting all of the material cut ahead of time, so that way we can process it a lot easier. Inside this crate we have a selection of 1045 TGP bar stock in different diameters, pre-cut to different lengths. Now in this case, my steel supplier was very generous and I was able to work with them because of the quantity of cuts, and they were able to cut me a deal. And so I spent a little bit more to get all this stuff pre-cut, but it's going to save us a tremendous amount of time at the bandsaw, so we can go ahead and immediately start processing this material and be effective with our time. So we'll go ahead and get a couple of these pieces unboxed and give you more details on the parts. Here's a closer look at 3 of the parts we're going to be making. We need to make 100 bolts, 100 washers, and 100 pins. These parts are not the exact parts we are going to be making. I'm intentionally holding back some of the details, but just know that these parts are not available off the shelf. They have a couple features that make them unique, and that's why we're manufacturing them. Since these parts are pretty easy in their own right, we're not going to focus on how we make each individual part, but we are going to try to bring you in and show the workflow process of how we're going through each step, because I think that is going to be a lot more interesting. Behind the parts here, we have the materials for each. We have this shorter piece pre-cut for our pin. We actually have this longer piece for this bolt, and we have this even longer piece for the washers. We're starting off this assembly line over at the beloved Blue lathe. Now this lathe is quite worn, and it is probably one of the least rigid lathes in the shop, but it does still do good work, and we are using it to get all of these blanks roughed out. Right now we're going to be starting off by making the bolts, and the first step that I need to do is to bring all of these pre-cut rods to length. Now I could rely on the saw cut face. The shop does a very good job pre-cutting those, but I want to be able to touch off on the end, and I want good repeatability. So I tried doing this without doing that, and because I'm flipping the part around, we introduced a little bit of error, and I want to eliminate that. So we're adding an extra step of facing both sides first before we start, and then we have a stop inside the chuck. So when we go to do our rough machining on the blank, we machine one section, we open the chuck, flip it around, register that off the positive stop, and machine our other features. This is probably where a bulk amount of machining is going to happen. At the next stage, we're focused more on finishing out those bearing journals. So over here, I'm roughing the blank down. We're putting in our thread relief and doing our chamfers. And then once everything is done, we're going to send those parts down the line to the next lathe to continue the operations. As we move through this process, I'm going to do my best to share with you some of the things I'm learning. I'm not afraid to admit that I have a ton to learn when it comes to machining, and especially large quantities. This is something that's very new to me. My shop is not really set up to process this volume of parts, so I went around and added a bench at every machine station we're going to be using, and in this case, this one's really simple, just a makeshift bench with a divider, keeps the parts that I need to process on one side and the parts that are done on another side. This means that Daniel can come up and grab them when he's ready, and then I know where to pull from. It just keeps me organized. I also figured out what inserts I'm going to need so I can stay over at the machine, and got my metrology set up so I can double check things as we're working. The other thing that's really crucial is because I'm having some help via Daniel and maybe a couple other guys, I wanted to be efficient with their time, also because I'm paying them, and I didn't want too much finagling around while they're here if we can avoid it. So what I'm doing is I'm going through each station and running about 5 or 10 parts and making those mistakes on my own time and dialing in my DRO presets and offsets and figuring out all of that stuff ahead of time. With all these cut to length and faced, we're ready to start roughing this out. So the first step is we're going to machine this down to a specific diameter and length, and then we're going to do one more pass, and then we're going to come in here and machine a shoulder for the thread, cut our thread reliefs, and chamfer everything. All right, we're gonna switch our tool to tool 2. We're gonna do our first grooving op. That's it. Tool 3 on the DRO. Second grooving op. And I've already zeroed all these, 998. Fourth tool. Gonna do our chamfer for the lead-in for the thread. Nice and heavy. We're going to chamfer the back side. And we're going to chamfer over here. That's our first side roughed out. We'll go ahead and get this flipped around and repeat that process. Register off that positive stop. Back to tool 1. And we continue on. Well, unfortunately, we have our first batch of failure, and I wanted to be as methodical as I could, but there's always things that pop up that you don't see. So I've made about 10 of these blanks so far. The first 5 were loss leaders. I knew they would be. I was using them to test surface finish on the next stop, but I thought I had 5 of these that were ready to go, and the reality is during my QC, which is pretty important, we caught a mistake. And the mistake is that on half of the side of these bolts, the length is perfect. The other half, all of them are short by about 60 to 80 thousandths. What I realized was when I made the stop that these bottom out on, I used a spade drill. And the hole in the bottom is chamfered a little bit, matching the angle of the drill. Well, when I chamfer the end on the first stop and flip it, that chamfer allows this to register deeper in my stop, and therefore all my measurements were off. So once we caught that, I went ahead and pulled that stop out, made sure that bottom in there was just square all the way across, and we were able to make one. I double checked it. What I'm actually doing is I have enough of these calipers laying around, so I have a couple preset to the length. So as I'm going, I'm just double checking with one for one shoulder length. I'll bring the other one that's longer, double check it, and I think I got it dialed in, but I thought I was good, and then I wasn't. So that's kind of what happened there. So we're gonna continue roughing these out, and then we'll pick up with Daniel and what he's gonna be doing, which is making these cleanup passes on all these bolt shoulders. So Daniel's over at the tapping station, and he's having a problem with the thread of the tapping arm not fully forming at the bottom. So what we're doing is we're modifying a die so that the last part of the cutting threads will be closer to the shoulder.
We're set up on Kyle's tapping machine over here. We have a 16mm die. We're gonna tap threads into this shoulder. This is gonna be a machine screw, so it'll end up looking like this guy right here. And instead of single point cutting these threads, it's way quicker to cut them with the die, especially because he has this nice tapping machine. So I'm gonna cut these threads, and I'm gonna check it with a go, no-go gauge. So we're gonna do that now. All right, so we're set up on Kyle's tapping machine over here, and we're gonna cut some threads into some parts that are gonna look like these. And we have a few options for how we're gonna cut threads like these, and we're using the tapping machine because we have 300 of these to make, and it would be a total pain to single point thread these. We don't have a CNC lathe, so Kyle has this great tapping machine we're gonna utilize. We have a 16mm die set up in this, and a nice fixture, so it's going to be really easy to knock these out accurately. One issue that we ran into as we're testing these is these threads we can't cut all the way up to this shoulder because these dies have a lead in. So there's a little bit of this last thread that's preventing us from bottoming the threads out up to this shoulder. This is a bearing journal for a radial bearing, and obviously we're gonna chop these, so this is one screw and this is another screw. This meat in the middle is just to hold it. So what I'm doing right now is cutting the bulk of these threads out, and we're gonna have to chase out this last 2 or 3 threads at the bottom with a custom die that Kyle Vanover is machining. So we're gonna try that out. But right now, I'm just gonna cut these threads as close as I can to this shoulder. So I have Molly D. This is a really great lubricant for cutting threads on a die like this. This is a pretty aggressive operation. I can feel this part physically get hot from the forces, the cutting forces, so good lubrication. Kyle was troubleshooting a lot of different lubricants and found that Molly D worked the best, and I agree. Cutting threads with a die notoriously picks up a nasty burr, and the finish we're getting off of this has been working pretty well. So after we cut the threads in each one of these parts, we're checking it with go, no-go gauges. This is our go gauge. This is our no-go. So if the thread is not cut properly, this no-go gauge will not thread on all the way. So it gets tight right there. So we know that this thread is good because this thread's on all the way. And I don't know if you can see this, but right at the bottom, there's like maybe a 30-second of an air gap between the face of this go gauge and the shoulder of this bearing journal. So that gap is what we're trying to overcome with the die that Kyle is modifying so that we can thread this face all the way up to this shoulder here. That's the goal.
All right, so we've been making some good progress on these pins. A lot of work roughing these out, making sure all the journals are prepped for Daniel and all the undercuts are in the right spot, but we are moving through this as efficiently as we can. Blue Lathe is doing an excellent job, making lots of chips. We're trying to move as fast as possible without wearing out the insert prematurely, and everything seems to be smooth so far. I think we've probably done about 30 to 40% of them at this point, and we have the process really dialed in. We had a lot of problems in the beginning just trying to figure out some details, but the last 10 or so I've made are very close on diameter and are really set up the next step down the line really well. All right, we're over here at the second station, and this station is going to be for finishing out the journal. Now, I struggled a lot at this station for trying to get a consistent finish and the tolerance that I wanted. So on this part over here, the tolerance that I've set for myself is plus or minus 1 thou, but more specifically, repeatability. I can hit 1 thou all day, even better than that, but on 100 parts, to have all 100 parts be within 8/10 of each other manually, that's a little bit more of a challenge. So in the beginning, I was messing with different cutters and I was getting pretty good results, plus or minus 1.5 thou, but I wanted to dial it in a little bit better than that. And so what I figured out works the best with the tooling that I have is we're using a DNMG 431. It is a core alloy insert, so it's a really nice insert, so it's not like a cheap Chinese one or anything. It's a good quality unit. We're going to be taking about a 20 thou depth of cut, and I tested 25 thou, 30 thou, 5 thou, 10 thou. 30 thou seems to give the best finish and good repeatability, and we're running about 1280 RPMs with 7.3 thou per rev. So the goal here at the station is to take the parts that we roughed at the blue lathe, and Danny is going to be chucking these up in the collet. We have a collet closer, and then he's going to take the setup here, bring it to size, and basically skim the bearing journal on all of the parts that I'm bringing over to him. And when he's done, all of those parts should be within about 8/10 of each other. He's shooting for the middle of the tolerance zone, and so far on the parts that he's done, everyone has been within spec, which is really, really nice. So from that, I'm gonna give it over to Daniel and let him do his thing, but that's pretty much what we're working with over here.
So I was noticing when I'm checking this bearing journal with a micrometer on the lathe right after I cut it, the part is warm enough where if I take a reading on the machine, it'll be a few tenths plus, because this thermal expansion, this journal grows when it gets hot. So I was noticing that as much as I'd like to mic it on the machine and make adjustments right there, it makes sense to pull it out, cut both sides, pull it out, and then check it to give it a couple minutes to cool down. Because right now I'm at 0.6686, and when I checked it on the machine I was 0.6689. So 0.3 plus on the machine. My tolerance is I need to be between 0.668 and 0.669. So I think that's relatively tight tolerances to do manually and repeatably. So because of that, I need to make sure I'm checking the stuff at the same temperature, otherwise it'll be different. All right, so we've got about half of these parts cut out as far as the bearing journals go, and so far we're in really good shape. There's nothing else that I think we can really improve on our whole process here, but I think I can emphasize that the right setups and the right tooling and the right feeds and speeds give accurate and repeatable parts, and this whole setup is a testament to that, because I'm hitting my mark every single time within tenths. On a manual machine, I'm at 0.668. And I think that's difficult to do every single time, over and over. So Kyle spent a good amount of time proofing out his whole workflow and how this stuff was gonna go. And it really shows, because I can come in and just knock out a whole batch of parts in a few hours, and everyone is good and we didn't scrap anything.
We've been working on the bolts for a little bit now, and we're going to take a break from that part and move over here to these pins. Now these pins are very simple in concept, but like everything else, the execution here is important. So initially what I was going to do is I was going to take these over to the LeBlanc, because we have the collet closer, slide these in, face and chamfer one side, flip it, face and chamfer the other side. But because these are saw cut, all of these have a burr going around the end, and the collets that I have are brand new and they're really tight. So it's kind of a pain to slide these in, and you got to kind of tap them, and then once they pass the end, then they slide easy. And it's just taken a little bit longer. The other thing is the chamfering tool that I'm using to face these. Turns out that we need to take off like 350 to 400 thousandths from both sides. They saw cut these very consistent, but they're oversized by about 1/8 of an inch from what I spec'd. And to simplify things, what we're going to do is we're going to come over here to the blue lathe. We're going to face and chamfer with the same tool, and then we're going to put that in a tray. And once we have all of these chamfered and faced on one end, we're going to take it over to the LeBlanc, and we're just going to part off. So instead of trying to machine off 300 thousandths off the end, we'll just part it, and that should leave a nice clean finish. It should be fast, and then we chamfer it and we're done. So let's go ahead and get these chucked up, and we'll start facing one side. I'm going to up my feed rate. Might be a little fast. Just experimenting here. Actually, I think where we had it was better. I want to go as aggressive as I can without the cutter pushing off. That looks pretty good. We altered our setup a little bit. I moved up my pins over here on the lathe so I can just grab them, turn them around, drop them. And what I'm doing, because this lathe has a slower ramp down, is I'm feeding the pin, I'm facing, and I'm turning it off, and I'm just chamfering when it spins down to kind of save time. So we'll give you a little sample here. Face, power off, chamfer, grab, pull it out, spin it around, grab another one. All right, we're over here at the LeBlanc, and we're going to part all these down to the right length and use our collet closer. So I'm going to grab one over here, slide it in, start it up. And we've tried with and without coolant. Without seems to work fine. It's less messy. Back it out, turn it off, unlock it, put it in the tray. Grab one, slide it in, make sure it bottoms, lock it, start it, part it. Pretty nice, pretty efficient. We got all these parted to length, so we're gonna come in here and chamfer all these. I've already done 17 of them here. So we're using the collet closer and being as efficient as we can be. So let's get going. Nice having the brake on this machine, nice and quick.
Hi, my name is Christian. I'm helping out Kyle today in his shop. We're going to be drilling these holes through these pins so they could get 5mm thread later. Let's get started. So we got to add a little oil. All right, add a little more.
Christian's been doing an excellent job drilling these holes, but we have run into a couple problems along the way. The first is that the drill bits aren't lasting super long. I think we're getting like 8 or 10 pins per drill bit, and these drill bits are cheap, but I do have a sharpening station set up over there. So as Christian is drilling these and he goes through like 5 or 6 of them, I'll take them over there and quickly sharpen them up, and then we can get more pins. We are having to use a lot of cutting fluid and have the speeds and feeds set properly. But other than that, everything's going relatively smooth. Typically, I like to sharpen my drill bits on a bench grinder or the belt grinder, but I do have this Tormac back from when we did woodworking, and it does a really nice job leaving a perfect grind. And especially with some of these smaller drill bits, it can be a little hard to see. So we have this setup here. I don't remember what this is called. It's a fancy setup that we use on the Tormac, and I can just get the drill grind dialed in perfectly. And we've been able to just take the drill bit, set it up. We'll turn the Tormac on, and then you come and you basically grind one flute, and then you take this out, you flip it, and then you grind the other flute, and you can even put a split point on it, which is really, really cool. So this has been really nice for this job on helping us stay cost efficient with using the same drill bits. We have a pretty simple station over here. Christian is basically just chamfering these parts, so that way when he goes to tap them, they will work out a little bit nicer and the tap will be able to get started easier. He has our trays, and these are just taking a couple seconds each one and getting all of them prepared for tapping on the first side. We're over here at the Lion lathe working on the next set of parts, and we need to make 100 of these washers. These parts are relatively simple, but there are a few things I needed to figure out to make these more efficiently. This part is going to be faced in another operation, and then we're going to drill 2 holes and chamfer those. But in this station, we're basically getting these on size and then parting them to a rough length. So overall, the right way to do this manually would be to buy the material on size and use a collet chuck and closer like we have on the LeBlanc. Feed this out, part it, feed it out, call it done. We decided to use this machine because it has coolant, which just increases the parting life and makes the parting go a little bit smoother. And it's a little bit overkill for this, so it does a fairly good job parting because it's fairly rigid for the size. We did have a couple problems. The first of which is this machine is very long and I'm on some unstable concrete. So I needed to re-level the machine before we even started the job, not for accuracy, but because this chuck/lathe vibrates pretty bad over 800 RPMs if this machine is basically balancing on the points. For a lot of the work I do, I run this thing below 500 or 600 RPM, and it doesn't matter. I adjust the feet here and there, but we wanted to run a higher RPM for surface finish and speed, and so we just needed to get the lathe re-leveled before we got started. Also, we have the quick indexing tool post over here, which I thought would speed up the job because we could machine down the OD first, and then when we're done, flip around, leave our DRO set, nothing changes, and we can be nice and efficient. So that's been working out really well. So we feed the material out like 6 inches. That's about the limit that I can bring it out where my surface finish doesn't degrade and develop chatter. We machine down the OD, and then we're able to part them off. It does chatter a little bit at the end during parting because the stick out is too far, but I can get about 8 different washers out of that operation, and we're going to be facing them anyway, and the chatter does not actually show up in the face anyway, so it's a good compromise. A little bit of chatter is expected. I was messing around with the feed rates before. I had the parting feed rate higher. It actually parts better, produces a better chip, but at the end, where it breaks off, the cutting force was higher, and as a result, I was burning through more inserts than I wanted, so I went ahead and backed it back a little bit, which is giving us a little bit of a stringier chip initially. I will also say that I'm compromising on the feed rate a little bit. I'm trying to minimize RPM changes and feed rate changes as much as possible because it's an extra step. So I've messed with the feeds and speeds a bunch, and what I figured out is this is working. The tool life is decent, the finish is decent, and I can actually leave the feed rate the same for the parting and for the machining, and all I do is change the RPM from 800 down to 500. Ideally, we'd get the feed rate a little higher on the parting based on personal experience, and maybe even decrease the spindle speed a little bit. But this is kind of a medium where it works both ways, but I have to do less changing. We're over at the LeBlanc lathe continuing on with these washers. This is how it came off the Lion lathe, and you've seen that in the last clip. And the goal is to get it to this stage where it's fully faced 2-dimension and chamfered on both sides. This lathe is working absolutely perfect for it because we have the high RPM and we have the collet closer. So I went ahead and picked up a machinable collet, and we have this set up where I machine the inside to the exact diameter plus about 5/10 thousandths. Put this in and go ahead and grip on that, do our machining, take it out, flip it over. A couple things that we've learned along the way. First off, when this comes off the line lathe, it actually had a burr on either side where we parted it. And what I figured out, and I didn't show, is I brought all of these, all 120 or 30 of them, over to the blue lathe, and I just chamfered each side to get rid of that burr. I started out doing this by hand on the Scotch-Brite wheel, figuring it would be pretty quick, but it actually was faster to take it over to the blue lathe and chamfer it, flip it, chamfer it. That chamfer is going to come off in this step. And so it's not critical, but the reason why that mattered is I was having a hard time getting this in and out of the collet quickly because of that burr. So by removing the burr and chamfering both sides, it added an extra step over there, but it allowed me to work much faster over here, which I think did save time overall. The other thing that is noteworthy is the size of this. I started out by like 2 thousandths oversized, and it was just too tight. I don't know how these are supposed to be set up because I've never used one, but I really wanted to allow this to be set up so that these kind of pop out. And I machined this about 10 thousandths oversized, which seems a little oversized, but that allowed me to get these in and out nice and easy. And there is a little bit of a difference in size, a couple thousandths, very minor. So it accounted for that, and it's working really, really nicely. All right, so we'll get this in here. Face it. Chamfer. Spin down. Pop out. Put in. Clamp. Bring it down to 250. Chamfer, turn off, pop out, put in the box. Grab another one. Face. Chamfer, turn off, pop out. Put in, clamp, turn on, go down to final dimension. Chamfer, turn off, pop out, box. So you can see how quick and efficient it is. Originally this collet was sticking, it wouldn't pop these out. And all we did was I just put it in the forward position and lubricated behind it, and that made a huge difference to get this collet to kind of retract forward. But it's really efficient, and I've able to face both sides of these in about an hour and a half, so that's like a minute per one, maybe 40 seconds, so fairly efficient, and I'm really happy with how it's coming together. Over at the Bridgeport, just getting these washers finished out. They're coming off the LeBlanc nice like that. And when they're done, we want them to have 2 holes with chamfers. Pretty easy setup, not a lot of learning, not a lot of mistakes over here. Basically, we have the soft jaws, which are a really nice fixturing feature, so we can bring these in and out quickly and repeatably. We're drilling 1 hole, we're jogging over a certain amount and drilling the second hole. We are using a chamfer drill bit to save some time. The only problem with using these is that the speed for the tip is significantly different than the speed for the chamfer. So in order to save time, we're compromising. We're running this at about 1500 RPM, which is fine for the tip, but way too fast for the chamfer. But we're using a lot of oil, and we're not dwelling too long on the chamfer, and it seems to work out pretty good. In the beginning, I started out running, 2,000, 2,200 for the tip, and then with the VFD, I slowed it way down for the chamfer, and I didn't really see that big of a difference in surface finish, so we just cut that step out, and if the cutters last a little bit less long, not too critical, they're not too expensive, but using lots of lubrication certainly helps prolong the life. So with all that, let me show you how we're looking and bring you in close. Grab one from the bin, put it in, speed handle, drill, lots of oil. Not gonna feed it too fast. I don't wanna burn out my chamfer. Jog over a certain amount, generous amount of oil. Leave the spindle running, blow it out, put it in the tray, bring the new one, drop it in, keep going. For the oil, we're just using hydraulic oil. It's cheap, it works well. Motor oil would be good. Dark cutting fluid would be even better, but I had this, and we have a nice little pump set up here, so we just got this right behind the Bridgeport. When we run out, we just fill this up and keep moving. Keeps us nice and efficient. Oil is cheaper than cutters, so just more gracious with the oil, and keeps us moving right along, less tool changes and less cutter replacement. Christian's over here working on tapping these pins. Pretty straightforward. He's using an M6 tap and using some Molly D. And we have the tapping arm set to a depth stop. He's cleaning it off, using the lubricant, and just kind of working through this pile that he was working on drilling. Overall, not a crazy amount of difficulty over here, and everything seems to be working fine. Ideally, we would be using a clutched tap driver, but when I bought this kit, I didn't have the metric drivers. So we're just holding the collet in an ER32 setup. So there is no clutch protection, but so far we have yet to break a tap, and it seems to be working out just fine. Other than that, we did make this cool setup to hold 4, but it doesn't work very well. They spin, so we're back to using the chuck, and it seems to be working great. We're continuing on making these pins, and we've had quite a lot of problems on a pretty simple part, but we've come up with some good solutions. So in the last couple shots, you saw us using these collet blocks to locate our pins, so that way we could keep the position, because these pins get holes on both sides. And what was ended up happening was there was too much effort to slide this in and out of the collet. It was scratching the part unnecessarily, and more importantly, the pins in the bottom were just kind of a pain to line up, and the accuracy was not that great. So that was version 1. Version 2 was these 3D printed jaws that I came up with, and these jaws, instead of relying on the holes, we actually screw in some bolts, and then when you slide these in, the bolts register here. And that was going to give us the alignment and improve the speed for clamping and unclamping. We used these, they're ABS GF. They did work, but I think because they're plastic and they had some give, they allowed for a little bit of variance in the way that these were clamped. So the positioning was not 100% dead on, and the accuracy between the holes was still a problem. So after all of that didn't work out, we switched to making the same set of jaws out of aluminum, and it's working out much better. We still, however, had a problem with the accuracy of the holes in terms of the distance to the side. So the distance between the holes was fine, but sometimes we'd make these and they would be, both holes would be 10 thousandths that way, other times they'd be 15 thousandths that way, and it would be sort of random. And the reason for that is we're not spot drilling these holes. So when I came in and just started drilling with a non-split point drill bit, the holes would migrate one side to the other. And I really didn't want to use a spot drill because it's gonna take an extra step. So what we did is we actually switched over to a cobalt split point drill bit. And by doing that and coming down and just kind of quickly pecking before we commit to drilling, that allowed the hole to stay on center and not deflect side to side. Since making that change, we've been able to manufacture these where the distance from one hole to the side and one hole to the side on the other is within like 1.5 thou, 2 thou, which is plenty good. All right, so we screwed our bolts in the bottom. We're gonna leave the spindle running, bring this in. I keep it high, I bring it above, I twist it until it drops. There it is. Usually it's a little quicker, but you know how it is when you're filming something. It takes longer. We'll come in here with our oil and we'll just do a little peck, just quickly to establish. Then we drill, oil. I have a stop set to a specified depth. Pop out, move over, same thing. We'll do a quick peck. And then we'll take it out, and that's that one drilled. And then I'll go ahead and just measure these. I've been measuring these with the Unimic. I come in here with a pin and measure it on either side just to confirm that it's within spec. And then we'll put it in the tray and move on to the next one.
So I'm parting all these off, and they're double-sided. If you guys remember, there was another screw over here. So I'm parting these off of the blanks, and it's going really well. It's a pretty easy setup. Kyle has a great lathe that he spent a good amount of money on, and it's paying for itself because we're making good parts every single time, repeatably. So I'm just parting these off and using flood coolant. And these are miking up within 2 thousandths every single time. So I'm just cranking them out. I mean, I've been here for maybe an hour and a half or something like that. So I'm over here on the LeBlanc still, doing one more operation before it goes to the CNC behind me. I need to do a pre-drill for the Allen drive, the 3/8 Allen drive. So I'm doing the pre-drill on here, and we're having some issues with tool breakage on the CNC, so we had to mess around with the correct pre-drill size to give us the right amount of clearance for the chips, and just so it's not a sloppy fit for an actual Allen key. So I'm set up over here and I'm just cranking these out. We have a, I don't know what this is called, a tool post drill mount, something like that.
I'm sure it has a fancy name.
Yeah, we indicated it in, we put a coaxial indicator on it so it's nice and centered with the chuck. We're getting really minimal run out with the drill, and we're power feeding, which I love doing. So nice and easy, great looking chips over here. So I'm about a quarter of the way through, and we're just gonna keep going.
All right, we're over here at the CNC machine finishing out the last op on these bolts. I have been doing a lot of learning over here, a lot of broken end mills, but luckily these end mills aren't too expensive. I originally set up this vise so we could do 6 at a time, but Danny figured out that these ends were not actually clamping properly, and so we were breaking end mills because the bolts were spinning around. And I had no idea. When I was testing this, I was only testing like a couple at a time, and for the first time when I ran all 6, I found that issue out. Aside from that, everything has been mostly working. We're just trying to get the depth of the drill bit correct, so that way we can have a successful milling op. Our speeds and feeds are not too aggressive, but I think because we have full engagement on the finishing pass, it is a lot for a small end mill. So we want to try to be a little bit on the conservative side. And so far, the last 5 or 6 we've run, we haven't had any problems, and I think we're good to go. So we'll run 2 at a time. We'll take them out while we're working on other stuff, put 2 in, and just kind of keep it rolling. Rounding out this job, we have the absolute last operation, and that is going to be finishing out these 20 pins by tapping the other side. Now you've seen us tap the other side and some of this side as well, but we have a couple changes I want to discuss. First off, we got these vice jaws set up to where they are working. We're using the same work holding method over at the bridge port where we index off the pins. We 3D printed another set of jaws, and now we have the notch in the bottom so that these will not spin, which increases our efficiency, and it's nice because we got the quick cam action. We'll pull these out, drop them in, clamp them, get working. Also, we've switched from using the Molly D to Anchorlube. Anchorlube was worse for the external threading, but somehow seems to be better for the internal threading. Maybe because it grips to the tap a little bit better, but it seems to work a little bit better. Also, originally I was using the fixed ER32 collet holder for the M6 taps, but the problem is there's no clutch. Luckily, I had this clutch that did fit the M5 taps, but I've gone through and broke multiple M5 taps, and basically what I figured out is the amount of torque that it takes to run this tap down is right at the edge of what it takes to snap a tap. And when using the clutch, a lot of times the hole will jam up and the clutch will start clutching out. And if it clutches out too much, meaning if you hold down the trigger too long, that vibrating or tweaking will actually snap the tap. So even though this is designed to save the tap, it does initially, but too many cycles of like impacting, which is what happens when this kind of cams out, I think it's weakening the tap from the shock load. So I've actually gone back to the rigid holder, and I haven't broken a single tap yet, which is kind of the opposite of what you would think. But basically the tap is not allowed to move and cam out at all, and I've just gotten better results doing that. So we're gonna come in here and get the last 20 of these threaded, and then we should be all done with this job. All right, let's show you in real time how we do this. Have a stop set So once it hits a certain depth, I was blowing out the chips initially, but I have found that at least on this job, it doesn't really seem to make a difference. I'm actually breaking less taps now, being sloppier with my setup than I was blowing the chips off, using the Molly D. Which is quite interesting, to be honest. I'm putting a little bit of downward pressure on the tap once we start, and then once it engages, kind of let off and let it do its thing. You can kind of hear it squeak a little bit before it would just kind of clutch out. There we go. There's 4 done. I would blow these off. I don't have my air hose set up over here. Go ahead and move these and show you how quick I can reload these. We're off to the races. Well, you get the idea. So I'll continue tapping these and we'll see you at the end. And I'll show you all the finished parts. Well guys, we are done and I couldn't be more excited about it. We've been working really hard on this job over the last couple weeks. And as you can see, we've had some other jobs in the shop that I haven't delivered yet. But we got 100 washers, 100 bolts, and 100 pins. And overall, this project turned out above my expectation in terms of quality. And I think the customer is gonna be really, really happy. We tried to bring you along the way and focus on the mistakes and the setups. So this video was a little bit different than my typical video. Overall, I showed you pretty much everything except the bolts. We really struggled at the beginning and at the end to get a consistent size. So I worked a lot with the CNC program trying to get this dialed in. And at the end of the day, I ran slow and I did multiple spring passes, and that got me the best result. But even so, I was changing out the end mills about every 15 bolts. And what I found out is that the end mills were wearing, and as they were getting dull, they were deflecting even more. So as I got up in the bolt count on an end mill, I would need to adjust the tool compensation. And even in the bottom of the pocket, it would deflect just a little bit, so it'd be a little bit looser at the top and a little tighter at the bottom. I think it's going to be more than good enough for what these are. These are just functional. They're not aerospace parts. But I think next time I'm going to go with the broaching. I think the broaching will be a little bit more consistent. I think I was just asking a lot out of a 1/8 inch end mill. Cycle time on this, we started at like 2 or 3 minutes a bolt. By the time I was done, it was taking like 7 minutes a bolt between the contours and the adaptive. And that is giving me the best finish and the best consistency. But guys, that is a lot of time just to come in there and clean up those corners. I think I have maybe 10 to 12 hours just machining all the hexes, which is super excessive. But I am still learning, and we did get the result, but I don't know that it's the most efficient setup. But yeah, other than that, I hope you enjoyed the video. If you have any comments, let me know down below. If you think I should do any setups different, please tell me. I'm not afraid to admit that we make mistakes and we have a lot to learn, and I would love to do that. So until we see you on the next video, get out there and make something cool.